6.1 Inverse circle function. So the property of the inverse function, it's the same way when we have the algebra. The way we define the inverse function, we put a power -1 on the top right corner, and we call that f inverse. The idea of the inverse is the input x and the output y, they will swap when you are finding the inverse function. So the domain will change to the range, and the range will turn to the domain. So the domain of the f is the range of the inverse function, and the range of the domain, it will turn to the domain of the inverse function. The range of the function will turn to the domain of the inverse function. A function is one-to-one or has the inverse. So we need to restrict the domain when our function is not a one-to-one function. For example, the first function is a sine function. Sine function is a periodic function, which is the curve will continue forever. So if we don't restrict the domain, if we draw the horizontal line to do the test, because the horizontal line passing through the graph 2 points at a time, so that indicate it failed on the one-to-one test. On one-to-one test, so when the function fail on the one-to-one test, that means there's no inverse. But in order to find the inverse, we have to restrict the domain. Restrict the domain. So use this concept. We want to find the domain. We want to find the inverse of the sine function. We restrict the domain from -π/2 up to π/2. So within this interval, which is within this domain, we can find the inverse. When you draw the horizontal line, it passing through the graph 1 point at a time. That indicate, yes, you can find the inverse within this domain. So the notation, we write down the sine inverse, which is we put a power -1 on the top right corner. Some of the book, they call the arc sine function. When you have the calculus, Cal 1, you will see arc sine very often. So when we have the arc sine function, the inside of the parenthesis, we have the sine value, which is the exact value we have been finding from the previous chapter. So when you have the sine inverse that carry an exact value, that will equal the angle. So the angle was the x value, which is the angle was the input. So from the angle, when we have the sine 30 degree, so we know the sine 30 degree is equal half. So the angle was the input. Exact value was the output. So this is original function, your plane sine function. Finding the inverse of the sine function, we swap the input and the output. So the exact value will go to the inside of the parenthesis, but we put the power -1 on the top right corner, and we put down the half into the inside of the parenthesis, and your output that will has the angle or the radian. So here's 30 degree, or we put a π/6. So from here, we know the information of the angle, and we go back to find the exact value. Or we give the exact value, we go back to find the angle. So when we restrict the domain of the sine function, we are targeting between -π/2 up to π/2. So the inverse of the graph of the sine function, it will turn to this direction. So pretty much the idea of getting the sine inverse function graph, we are respect to the y equal x. So when I draw the y equal x passing through the origin, the blue color curve was a sine function. Finding the inverse of the sine function, let me pick another color. So respect to the y equal x, we will getting this curve, the green color curve here. So this graph will represent, the green color graph will represent the inverse of the sine function. So all the domain on the sine function will turn to the range of the sine inverse function. So the thing you need to know is original function is a sine x. Inverse of the sine function would be the sine inverse x. The original function of the sine has a domain between negative power 2 up to power 2. The range is negative 1 up to 1. When they come to the sine inverse, your domain swap with the range. So your domain has between negative 1, 1, and the range between negative pi over 2 up to pi over 2. So your sine inverse now only has the range between pi over 2 and the pi over negative pi over 2. So they only have the inverse value between this interval. So how do we solve for the example like this question? So we need to find a y, and they tell us arc sine. Eventually, this is the inverse of the sine, and we know the information of the exact value. So with the sine inverse function, we only can finding the range between negative pi over 2 up to pi over 2. So which is doing this interval. Now, if you look at this interval here, the only number, the exact value that can produce root 3 over 2. This is a positive root 3 over 2, which is this number on quadrant 1, because on the quadrant 4, there is no positive root 3 over 2 that corresponding to the sine function. Your sine stay after. Your cosine stay in the front. Keep in mind the order stay the same. Here the order they don't swap. Okay. Alright, so your sine x is a root 3 over 2, which is when you go back to look at that degree angle would be pi over 3. So your y is equal to pi over 3. So that means when sine come to the 60 degree, the output would be root 3 over 2. Finding the inverse of the sine, and that exact value is negative half. If you look at the graph here, negative half, that corresponding to the sine x would be negative pi over 6. So this one we will have the y is equal to negative pi over 6. Cosine. The domain of the cosine function, the domain is between 0 and the pi. The range has the same like a sine between negative 1 and 1. So when the cosine function turns to the inverse of the cosine function, the domain and the range, they interchange. So the domain of the cosine of the inverse is between negative 1 and 1. The range of the inverse cosine is between 0, pi. So the way we finding the inverse of the cosine function, we only take the quadrant 1 and the quadrant 3. So they are rotate between back and forth between 0 and the pi. But however, sine is back and forth between negative pi over 2 up to pi over 2, because that would be the new range of the inverse function. So this is a new range of the cosine function. So we practice this one. Finding the inverse of the cosine root 2 over 2. So if you look at the root 2 over 2, cosine is the number in the front. So this would be the cosine. So your y is equal pi over 4. The cosine, inverse cosine, and that exact value is negative half. So the cosine is here, negative half. This is a cosine. So your degree or your radian would be 2 pi over 3. Tangent. The original function of the tangent, the domain has between negative power 2, comma power 2. Remember, this is the way we set up the argument of the two boundary. So we take the negative power 2, comma power 2. The range of the tangent is all real number. So when it comes to the inverse of the tangent, the domain will have the all real number. The range of the inverse tangent is between negative power 2, comma power 2. So tangent is pretty much the same graph like your inverse of the sine function. So when you are looking for tangent inverse, which is your tangent inverse of that exact value at the 1, tangent is getting from sine divided by cosine. So you have to sine divided by cosine. So we take the sine divided by cosine. Here's a pi over 4. So we have the root 2 over 2, comma root 2 over 2. So only ratio you can get a 1 would be pi over 2. So with this one, we will have the y is equal pi over. It's a pi over 4. Sorry, I talked too fast. It's a pi over 4. Finding the inverse of the tangent function, the exact value is negative root 3. Now, if you look at negative root 3, the ratio you can get the negative root 3 would be negative pi over 3. Because when we take the sine divided by cosine, you'll get a negative root 3 over 1, which is negative root 3. So that means the y is equal to negative pi over 3. The reason why we put a negative pi over, you can put a negative pi over 3, or you just subtract from 2. You add a 2 pi into it, convert into the positive value. But if you use a calculator to input the inverse of the tangent negative root 3, they will give you the negative pi over 3, because keep in mind the range of the tangent only between negative pi over 2, negative pi over 2 up to positive pi over 2. So that makes sense. This point will tend to negative pi over 6.